Top 10 tractors that were too advanced for their time. Most tractors are built for the present, but a few were built for a future that didn't exist yet, not because they were flawed, not because they lacked power, but because the industry wasn't ready for what they represented. Over the decades, engineers have introduced machines that challenged expectations. New drivetrains, new architectures, new philosophies of scale and control. Some were questioned, some were doubted. A few were quietly ignored, until the rest of the market eventually caught up. Starting at number 10, a tractor that confused people before it impressed them. Ranked 10th, International Harvester 35882+2. It confused people before it impressed them. The International Harvester 35882+2 didn't look like a traditional row crop tractor. It didn't look like a full articulated machine either. The cab sat forward. The articulation joint split the chassis in a way farmers weren't used to seeing. Visually, it felt unfinished. Technically, it wasn't. The 2+2 design combined the traction advantages of articulation with the familiarity of a row crop layout. Weight distribution improved. Power transfer was efficient. It solved real problems in certain field conditions. But the market wasn't evaluating torque curves or traction geometry. It was reacting to appearance. Farmers trusted what looked familiar. Dealers struggled to explain where it fit in the lineup. Was it a replacement for large row crop tractors? A light articulated machine? Something in between? And that in-between category was the problem. The 3588 wasn't a failure because it lacked engineering merit. It struggled because it challenged visual expectations before the industry was ready to rethink tractor architecture. That tension, innovation colliding with tradition, defines what it means to be ahead of your time. And it's only the beginning of this list. Ranked 9th, Minneapolis Moline G1000 Vista. It wasn't louder. It wasn't dramatically more powerful. It simply saw differently. The Minneapolis Moline G1000 Vista introduced a forward-thinking approach to operator visibility at a time when most tractors were still built around mechanical packaging first and human positioning second. The elevated operator platform and improved sightlines weren't cosmetic changes. They reflected a shift in design philosophy. Field efficiency is influenced by visibility. Implement alignment, row tracking, situational awareness. These details matter over long hours. Yet in its era, ergonomics rarely drove purchase decisions. Horsepower did. Durability did. The Vista quietly suggested something different. Operator perspective was part of performance. But that idea arrived before comfort, sightlines, and long-hour fatigue reduction became selling points. Many farmers saw it as stylistic variation rather than functional advancement. In hindsight, modern tractor cabins emphasize exactly what the Vista hinted at. Elevated visibility, better layout, operator-centered design. It didn't disrupt the market dramatically. It didn't fail spectacularly. It simply introduced thinking that wouldn't be fully appreciated until decades later. And further up this list, the gap between innovation and acceptance grows much wider. Ranked 8th, John Deere 8020. Four-wheel drive was not the problem. Timing was. When the John Deere 8020 appeared in 1960, it represented a serious departure from conventional row crop expectations. With a four-wheel drive articulated configuration delivering significantly more traction and pulling capability than most farms required at the time, it was built for scale that hadn't fully arrived yet. The engineering worked. The traction was undeniable. The power delivery was ahead of contemporary needs. But many operations were still structured around smaller acreages. Equipment fleets were built around two-wheel drive assumptions. Implements weren't yet demanding the kind of sustained pull the 8020 could provide. It wasn't that farmers doubted four-wheel drive forever. They doubted needing it. Large-scale consolidation and high-horsepower tillage would eventually make four-wheel drive mainstream. Decades later, articulated four-wheel drive tractors would become standard in big-acre operations. The 8020 simply arrived before that shift was inevitable. It wasn't misunderstood because it looked strange. It was premature because the agricultural landscape hadn't expanded to justify its potential. And as this list moves forward, the gap between what engineers built and what the industry was ready to adopt becomes even more pronounced. Rank 7th, New Holland Genesis 8770. It wasn't the horsepower that made farmers hesitate, it was the wiring. When the New Holland Genesis 8770 arrived in the 1990s, it brought a higher level of electronic integration than many operators were comfortable with. Engine management systems, digital controls, electronic monitoring, features designed to improve efficiency and precision. On paper, it was progress. In practice, it introduced uncertainty. For generations, tractors had been mechanical. Repairs were visible. Problems were tangible. If something failed, it could often be diagnosed with tools and experience. Electronics changed that equation. Now troubleshooting required diagnostics. Sensors replaced mechanical linkages. Reliability wasn't just about metal and torque. It was about circuitry. The Genesis platform wasn't flawed. In fact, it represented the direction the entire industry would eventually move toward. Electronically managed performance, precision farming compatibility, greater integration. But at the time, many operators weren't ready to trust a tractor that depended on systems they couldn't see or easily repair. Today, advanced electronics are standard across modern equipment. Back then, they felt like a risk. And further up this list, that risk becomes even more radical. Ranked 6th, Steiger Panther ST325. The machine wasn't excessive. The farms were still small. The Steiger Panther ST325 delivered articulated four-wheel drive power built for serious acreage. Wide stance, high draft capability, designed to pull large implements efficiently across long, uninterrupted passes. The engineering assumed scale, but in many regions, that scale hadn't fully materialized yet. Farm consolidation was still developing. Acreage expansion was happening, but unevenly. Many operations didn't yet require sustained high-horsepower, articulated platforms. The infrastructure of farming, equipment fleets, implement sizes, economic structures, was still transitioning. The Panther wasn't misunderstood because it looked strange. It was ahead because it anticipated where agriculture was heading. Large acre tillage, fewer passes, higher horsepower platforms replacing multiple smaller units. That model would eventually dominate major grain-producing regions. When that shift happened, articulated tractors became standard. But the Panther arrived before that inevitability felt obvious. It was built for the next version of farming, before that version had fully arrived. And further up this list, the gap between innovation and readiness becomes even more dramatic. Ranked 5th, JCB Fastrac 185-65. It moved like a truck. That was the problem. The JCB Fastrac 185-65 didn't just introduce more horsepower or improved traction. It introduced full suspension, high-speed road capability, and a chassis philosophy that blurred the line between tractor and transport vehicle. Traditional tractors were built for fields first. Road travel was secondary, slow, rigid, purely functional. The Fastrac reversed that assumption. With suspension on both axles and higher safe travel speeds, it treated road movement as part of productivity. It acknowledged that modern farms were geographically dispersed. Time between fields mattered, but at the time, many operators didn't view speed and suspension as necessities. A tractor wasn't supposed to feel like a lorry. It wasn't supposed to prioritize road comfort. The engineering was solid. The logic was sound. The resistance was philosophical. Only later, as farms expanded and logistics efficiency became critical, did the value of faster, more stable road travel become obvious. The Fastrac didn't fail because it was flawed. It arrived before farmers fully recognized that transit time was part of performance. And further up this list, innovation stops clashing with philosophy and starts redefining architecture itself. Ranked 4th, Claas Xerion 2500. It wasn't built as a single-purpose tractor. It was built as a system. The Claas Xerion 2500 challenged a long-standing assumption that a tractor should be a fixed-format machine with defined tasks. Instead, it introduced a modular platform concept, rotating cab, flexible ballast configurations, multi-role adaptability. This wasn't just about horsepower. It was about architecture. The rotating cab alone signaled something different. Forward-facing, rear-facing, adaptable to various high-demand applications. It blurred the line between traditional tractor and specialized equipment carrier. At the time, that flexibility confused parts of the market. Dealers were used to selling tractors by category: row crop, articulated, utility. The Xerion didn't fit cleanly into any of those boxes. It wasn't designed around a single dominant task. It was designed around system integration. That idea, a tractor as a modular, adaptable platform, would later influence how manufacturers approached large-scale equipment design. But when the Xerion first appeared, it felt unconventional, over-engineered, different for the sake of being different. In reality, it was pointing toward a future where tractors would become configurable platforms rather than single-role machines. And the machines still ahead didn't just challenge categories. They reshaped expectations across the entire industry. Ranked third, Fendt Favorite 926 Vario. At first, it felt unnecessary. The Fendt Favorite 926 Vario introduced a continuously variable transmission at a time when most operators trusted mechanical steps, gears they could feel, shifts they could anticipate. CVT removed those steps. Instead of fixed ratios, it delivered seamless power flow. No shift shock, no interruption, just continuous adjustment between engine speed and ground speed. To some farmers, that felt abstract. Where were the gears? What happened if it failed? Was smoothness worth the added complexity? The hesitation wasn't irrational. Mechanical transmissions had built decades of trust. CVT felt like replacing something proven with something invisible. But the advantage was real. Fuel efficiency improved. Operator fatigue decreased. Precision control became easier. Over time, what once felt experimental began to define premium tractor performance. Today, continuously variable transmissions are standard in high-end agricultural platforms. What was once questioned is now expected. The 926 Vario didn't just introduce a feature, it introduced a new benchmark. And the final two machines on this list didn't just influence components. They anticipated structural shifts in how farming itself would evolve. Ranked second, Big Bud 16 V-747. It wasn't just large, it was disproportionate to its era. When the Big Bud 16 V-747 was built in the late 1970s, it delivered nearly 760 horsepower through a massive 16-cylinder engine. Weighing well over 100,000 pounds and stretching close to 30 feet in length, it was engineered to pull enormous implements across a vast acreage. The machine itself worked. That was never the issue. The question was whether agriculture at the time required something of that scale. Large-scale consolidation had not yet become the dominant structure in many regions. Implement width, field planning, and economic models were still transitioning. The 16 V-747 anticipated megafarming before it became commonplace. It wasn't misunderstood because it was flawed. It was ahead because it assumed an industrialized version of agriculture that had not fully materialized. Decades later, as high-horsepower articulated tractors became standard on major grain operations, the logic behind its scale became clearer. The Big Bud didn't create modern large-scale farming, but it predicted it, and at number one, the story shifts from scale to architecture, from size to vision. In first place, Claas Xerion 3800 saddle track. It didn't just introduce features, it introduced a platform. The Claas Xerion 3800 saddle track represented a different way of thinking about what a tractor could be. Instead of designing a machine around a single dominant task, it was engineered as a configurable system, modular ballast distribution, high horsepower capability, and a cab architecture that could rotate to optimize visibility and application. The concept went beyond comfort or power. It redefined layout. The rotating cab wasn't novelty. It was functional flexibility, forward-facing for draft work, rear-facing for precision-mounted implements. The chassis allowed weight to be distributed strategically for demanding field conditions. At the time, many operators saw it as complex, over-engineered, different from established tractor formats. But modern agricultural equipment increasingly reflects this philosophy. Platform-based design, multi-role capability, adaptability across applications. The Xerion 3800 didn't merely anticipate larger farms. It anticipated that tractors would evolve from single-purpose machines into configurable systems. Being ahead of its time isn't always about speed or horsepower. Sometimes it's about redefining architecture before the rest of the industry realizes it needs to change. And in that sense, the Xerion didn't just predict the future, it quietly helped shape it. Being ahead of its time doesn't always mean being wrong. Sometimes it means arriving before the market is ready. Many of the ideas questioned in these machines are now standard across modern agriculture. Innovation rarely waits for permission, and in farming, the future often starts quietly.